take a look at this example where we want to expand x minus 2, that quantity, to the third power. This minus sign here adds a little bit of a twist into the system where students will often make mistakes. So I notice again that my value of n here, my power I'm taking this to, is the third in this case. So I need the n equals 3 row of Pascal's triangle. The n equals 3 row of Pascal's triangle has coefficients 1, 3, 3, and 1. So again, I showed you how to create that and where to go to get that in a previous video. So I need to go get that from Pascal's triangle, and I know I needed the n equals 3 row because this exponent was 3 right there. So now, I'm going to take the two pieces of the binomial. In this case, they're x and negative 2, and write them in parentheses after each one of these. So each one of these is going to get an x. And each one of these is going to get a negative 2. Like so. And then I'm going to fill in the powers on those. Again, starting at 3 on the x, I go down 3, 2, 1, 0, and then back up the other way, 3, 2, 1, 0. Remember, the powers on both of these pieces are supposed to total the original power every time with that. These 0 power ones are going to evaluate to just be 1, so I can cross those off. They're not going to have any effect on this. And now I just need to go ahead and simplify each of these terms individually. Here I have x to the third power times 1, which is just x to the third. Here I have negative 2 to the first power, which is negative 2, times 3, which is negative 6, and then the x squared. Here I have negative 2 to the second power, which is actually positive 4, times 3, which is 12. And then I have x to the first power, or just x. Down here I have negative 2 to the third power. Again, remember, anytime you take a negative number to an odd power, it will be negative. Anytime you take a negative number to an even power, it will be positive. So negative 2 to the third power is negative. It's negative 8, as a matter of fact, times 1, which is still negative 8. And then you have your terms here. Just a quick spot to double check. If this is a minus sign here, your terms should be alternating signs. I'm seeing positive, negative, so I'm seeing that alternating sign pattern. If you don't see that, you've probably made a sign mistake somewhere, so that's a good way to catch it. Finally, writing the expanded polynomial, I have x to the third, and then minus 6x squared plus 12x minus 8. If you were to write that out as x minus 2 times x minus 2 times x minus 2 and go through all the distributing correctly, you would end up at this same thing here. Again, I'm not sure which one would take more time with it only being a third power, but the higher that power becomes, the much more efficient this method becomes opposed to the alternative. So there's another example showing you how to deal with a minus sign in there. Let's continue to look at some more examples and see what could make this more complicated.